Okay, so you want to own a quarry. Find land with rock underneath it, drill a few holes, blast the stone apart, crush it, and sell it. That is the business plan in your head, and honestly, it sounds almost unfair. Your product has already been sitting underground for millions of years. You do not have to invent it, assemble it in a factory, or wrap it in expensive packaging. Road builders, concrete plants, airports, bridges, drainage systems, and foundations already need what you are selling. You just have to dig the rock out of the ground and start collecting money. Here is the problem. The rock itself is usually one of the cheapest parts of the entire operation. In 2025, the United States produced roughly 1.5 billion metric tons of crushed stone. The total value was about $27 billion. That works out to only around $18 per metric ton before delivery. A metric ton of stone can weigh more than a small car, yet the stone itself may sell for less than a restaurant meal. That is the first thing you need to understand. A quarry is not really a business built around expensive rock. It is a business built around moving enormous quantities of cheap rock. Land, machinery, fuel, maintenance, regulation, and transportation all compete for the same thin selling price. You are not trying to make a fortune on one valuable object. You are trying to make a few dollars on every ton, hundreds of thousands of times. If one part of the system slows down, those few dollars disappear very quickly, and the giant hole in the ground can start swallowing money faster than it ever produced it. Before buying anything, you must decide what kind of quarry you actually want to own, because not every hole filled with rock is the same business. A dimension stone quarry tries to remove large, intact blocks of granite, marble, or limestone. Those blocks may become countertops, building facades, monuments, or decorative stone. The value per ton can be much higher, but the stone must remain beautiful and unbroken. A construction aggregate quarry is different. It does not care whether the rock comes out in a perfect block, because the rock will be broken anyway. The quarry drills and blasts a rock face, then feeds the broken material through crushers. Screens separate the material into road base, concrete stone, asphalt aggregate, drainage stone, and railroad ballast. Sand and gravel pits may excavate loose material without blasting at all. These operations can look similar from the road while using completely different geology, equipment, and economics. For this video, we are focusing on the classic crushed stone quarry, the kind with benches cut into the earth, drilling rigs on the wall, giant loaders below, and a crushing plant shaking the site. From a distance, the model looks simple. Rock enters one end and money leaves the other. But the first thing you buy is not a crusher, a truck, or even the land. The first thing you buy is uncertainty. Imagine someone offers you 200 acres outside a rapidly growing city. The property sits near highways, construction is expanding nearby, and gray rock is visible at the surface. It looks perfect, so you buy the land for several $1 million. Then a geologist arrives, the drilling begins, and the perfect property starts changing. Only part of the site may contain stone strong enough for high-quality construction aggregate. Some rock may be heavily fractured, weathered, or filled with weak clay seams. Some may sit beneath so much soil and useless overburden that removing it costs more than the stone is worth. One section may contain groundwater, another may sit beneath protected wetlands, and another may be too close to the property line. That is the difference between having rock and having reserve. Rock is simply material in the ground. A reserve is material that can realistically be extracted, processed, permitted, and sold at a profit. Geologists drill core samples across the property and study how the rock changes with depth. They test strength, durability, chemistry, cavities, weak layers, clay seams, and groundwater. They also estimate how much waste must be removed before useful stone can be reached. Even then, the reserve number can change. If fuel prices rise, deep stone may become uneconomic. If customers demand a different specification, part of the deposit may lose value. If a permit limits the quarry depth, perfectly good stone may remain legally unreachable. So when you buy a quarry, you are not really buying acres. You are buying permitted, usable tons. Two properties of the same size can therefore have completely different value. Now suppose the geology is excellent and millions of tons of durable stone are waiting below the surface. You are near a growing city, the road access is good, and the land price makes sense. You still do not have a quarry. You have land where you hope to create noise, dust, truck traffic, blasting vibrations, and a permanent change to the landscape. The people living nearby may have a very different opinion. A new quarry can require zoning approval, mining permits, air permits, water permits, road approval, blasting compliance, and reclamation plans. The exact process changes by location, but one pattern appears almost everywhere. The closer you are to customers, the more valuable the quarry becomes. And the closer you are to customers, the more likely you are to be near homes, businesses, and angry neighbors. Residents may fear cracked foundations, dust, noise, falling property values, damaged roads, and changes to groundwater. Even when those concerns can be managed, the approval process may consume years of engineering fees, legal work, and carrying costs. And approval is never guaranteed. That is why an old quarry with existing zoning and permits may be worth far more than untouched land with the same rock. The scarce asset is not always the stone or even the hole. Sometimes the scarce asset is the legal right to keep making the hole deeper. Assume you survive the approval process. Now you must turn empty land into a functioning industrial operation. The equipment list begins with drilling. Before each blast, a drilling rig creates a carefully planned pattern of holes across the rock face. Those holes are loaded with explosives, but the goal is not the largest possible explosion. A good blast creates fragments small enough to load and process while leaving the remaining wall stable. If the pieces are too large, you need secondary braking. If the blast creates too many fines, you generate dust and low-value waste. If rock travels too far, the blast becomes dangerous. After blasting, excavators and wheel loaders move the broken stone into off-highway trucks. The trucks carry it to the primary crusher. The primary crusher reduces huge rocks into manageable pieces. Secondary and tertiary crushers reduce the material further. Vibrating screens separate the stone by size. Conveyors move each finished product into a different stockpile. A truck scale weighs every outgoing load. A laboratory checks whether the material meets customer specifications. Water trucks suppress dust on haul roads. Pumps remove rainwater and groundwater from the pit. Maintenance buildings keep the machinery alive. Internal roads must support loaded trucks moving continuously between the rock face, crusher, and stockpiles. A modern tracked jaw crusher alone can approach 7 figures. But the crusher is only one link in a much longer chain. You may also need loaders, excavators, haul trucks, screens, conveyors, generators, fuel storage, electrical systems, and environmental controls. Buying used equipment lowers the opening bill, but increases the risk of hydraulic failures, worn bearings, and unavailable parts. Financing preserves cash, but replaces the purchase price with fixed monthly obligations. The lender still expects payment when the crusher is broken. The lender still expects payment when heavy rain stops production. And the lender still expects payment when the construction market slows down. Before the first customer truck arrives, a greenfield quarry can already be a multi-million-dollar project. You cannot test this business with one cheap machine and expand later. A large part of the system must exist before meaningful production can begin. Once the quarry is operating, everything is measured in tons. Tons drilled, blasted, loaded, hauled, crushed, screened, and sold. And at every stage, the same ton creates another cost. The drill consumes fuel, parts, and labor. Explosives must be purchased, stored, and handled safely. The loader burns fuel lifting the stone. The haul truck burns more fuel carrying it uphill. The crusher uses electricity or diesel while its internal wear surfaces slowly destroy themselves. Screens wear out. Conveyor belts stretch, and bearings fail. Then the finished stone is handled again and loaded into the customer's truck. 1 ton may pass through several machines before it earns a single dollar. That is why quarry operators obsess over cost per ton. A tiny inefficiency looks harmless until it is multiplied by hundreds of thousands of tons. A badly designed turn that adds 30 seconds to every truck cycle can reduce production for the entire day. A crusher producing slightly too much fine material can convert valuable stone into a low-value stockpile. A loader that underfills every truck completes the same number of trips while delivering fewer saleable tons. This business is won or lost through thousands of repeated movements. A truck reversing, a bucket filling, a belt turning, and a customer waiting. Removing a few cents from each movement can create a major annual advantage. Ignoring those cents can leave a busy quarry wondering where the profit went. A customer does not usually call and ask for some rocks. They ask for a specific product with a precise size, shape, cleanliness, and durability. Concrete producers, road contractors, drainage projects, and railroads all need different material. The same deposit can therefore produce several products with different prices and different levels of demand. Large stone may become erosion control riprap. Intermediate stone may go into concrete or asphalt. Smaller material may become road base, while fine particles may sell cheaply or remain unsold. When 1 ton enters the crusher, the operator cannot choose freely what every particle becomes. The geology and crusher settings determine the mixture of sizes. Customers may want those sizes in completely different proportions. The profitable product can leave every morning, while an unwanted stockpile grows into a mountain. Operators adjust crusher settings, blend materials, wash stone, or find new buyers for lower value product. But every improvement adds equipment, energy, water, maintenance, and another calculation. The quarry does not make money by producing the most stone. It makes money by producing the stone the local market is willing to buy. Now we reach the most important part of the entire business: transportation. Crushed stone is extremely heavy compared with its selling price. Moving the aggregate can cost more than producing it. That means your real market is not the entire state or even the entire city. Your market is the area trucks can reach at a competitive delivered price. Imagine Quarry A produces stone for $15 per ton and sits 10 miles from the customer. Quarry B produces the same stone for $13 per ton, but sits 40 miles farther away. At the quarry gate, Quarry B looks more efficient. After trucking is included, Quarry A may win almost every order. A mediocre deposit in the right location can therefore be more valuable than an excellent deposit in the middle of nowhere. A typical aggregate truck carries only 20 to 25 tons, so a 100,000-ton project requires thousands of separate loads. Every extra mile adds fuel, driver time, tire wear, and fewer deliveries per day. Large companies sometimes use rail, barges, or ships, but those systems require terminals, infrastructure, and enormous volume. For most independent quarries, the road network is the market. Traffic congestion, weak bridges, residential roads, or a poor highway connection can erase a location advantage. The quarry may own the stone, but the route to the customer determines whether the stone can compete. Many quarries sell to asphalt plants, concrete producers, paving contractors, and general contractors rather than directly to government. Demand comes from public infrastructure, housing, factories, warehouses, schools, airports, offices, and data centers. A quarry serving several markets has protection, while one dependent on a single giant project carries concentration risk. A major highway contract may justify another shift, more workers, and another loader. But when the project ends, the equipment payment, payroll, and maintenance bill remain. When every machine is running, trucks move constantly, stockpiles grow, and the quarry feels unstoppable. But employees, insurance, security, monitoring, loans, and administration continue even when sales slow down. Diesel, electricity, tires, steel, crusher liners, bearings, and replacement parts constantly attack the margin. A quarry is a connected system, so one failed conveyor can eventually stop the screens, crusher, trucks, and customer delivery. Maintenance is an attempt to choose when the quarry stops instead of allowing the quarry to choose for you. Strong operators monitor vibration, oil, temperature, belts, and component wear before a small problem becomes an emergency. The quarry also pays for dust control, water management, environmental monitoring, safety training, inspections, berms, guards, and traffic systems. Explosives, unstable rock faces, conveyors, electricity, and giant trucks leave almost no room for careless mistake. Imagine a regional quarry selling 500,000 tons per year at an average of $20 per ton. That creates $10 million in annual product revenue, but direct production costs of $11 per ton remove $5.5 million. Management, insurance, taxes, interest, royalties, environmental work, equipment replacement, and reclamation consume much of what remains. At 500,000 tons, improving the margin by $1 adds $500,000, while $1 extra of cost removes it. Scale can spread fixed costs across more tons, but it also requires more customers, equipment, maintenance, debt, and reserve. Every truck leaving the gate carries away part of the quarry's fundamental asset, because the same ton can never be sold twice. Eventually, the remaining stone becomes too deep, too restricted, too expensive, or completely exhausted. Closing the quarry may require stable slopes, controlled water, removed equipment, restored vegetation, and years of reclamation work. A good quarry can be extraordinary, while a bad quarry can look identical and lose money underground, inside permits, on repairs, or along the delivery route. You are selling the right rock in the right size, from the right location, cheaply enough to move a mountain, one truckload at a time.